Okay, welcome back. This is your test prep. Unfortunately, I've just looked at the test I'm actually going to have you take, and it's a little harder than what I'm preparing you for, but that's good for you. It makes your mind expand. But this problem is something that should be a piece of cake for you. It will be shortly if it's not. However, this problem is too simple to show up on your actual test. But anyway, we do it. Convert everything into sines and cosines. Anytime you're translating things, unless it's 1 plus tangent squared, something like that, that you know is secant squared, convert it. So this is sine x over cosine x times cosecant x is 1 over sine x. Cosine x is, of course, itself cosine x minus sine x times cosine x. Now we're going to distribute this. It hits here, it hits here. When it hits here, we got a sine on top, sine on the bottom. They're going to cancel. Cosine on bottom, cosine on top, they're going to cancel. After this collision and this monumental destruction, we are left with just 1. Now it's going to be this times this, which I'll put over here. So we're going to have sine x, cosine x times sine x times cosine x. Cosine x on top, cosine x on the bottom, we are left with 1 minus sine squared x, which of course you know is cosine squared x. Piece of cake. Piece of cake. As I mentioned, though, this was just to remind you of some more basic kinds of things, because the truth is this is probably too easy to be on tests these days. Let me put one on that is going to be very nearly like the one on your test, which you'll be interested in. We are given a generic triangle with some basic information. And let me try and draw it as best I can. Okay, so here's angle beta or B. Here's alpha, and I'm starting to use gamma. This is the Greek letter gamma. And using a proper title, Greek gamma, and it's small gamma. Yeah, and this is going to correspond to side C. This is side B, and this is side A. You'll notice the book that we're using for this doesn't use this symbol. They usually use C in here. And the reason that I'm using this is because to get the pictures electronically on the blackboard, I have to use a particular format. And the only pictures that I had of this generic triangle were using this instead of C. And there's a program called LaTeX that I could be doing this with, but we don't have it. So anyway, we have some information here. We are given that B is equal to 70. And that A is equal to 60, and that angle alpha is equal to 35 degrees. And we're supposed to figure out how many triangles we can get out of this, right? A couple things. This really should be in some units of length. Let's just do meters. I didn't put it on there when I wrote it up. I don't remember. I took this problem from the book somewhere, and I don't remember if they actually put it in units or not. So how many triangles is there? Well, let's figure out some things, right? Let's figure out some other angles. We know from the law of sines that the sine of alpha, or the sine of 35 degrees, over side A, which is 60 meters, must equal the sine of beta over 70 meters. Doing some basic algebra here, and the meters will cancel out. We're going to have 70 over 60 times sine 35 degrees is equal to sine of beta. Let's see what that is. Pulling out our old calculator, noticing that I'm actually on degrees and not radians, which is important. So this is 35 sine times 70 divided by 60. So my trusty calculator says that sine beta is equal to 0.669172509, blah, blah, blah. That means that beta is equal to arc sine of 0.66917, blah, blah, blah. I'll hit my arc sine button, and I get 42.0032 degrees. We've been approximating to the 100, so we're just going to call this 42.00 degrees. Right? Or I'm just going to call it 42 degrees. But remember, we use the law of sines here. There's another possibility. It's also possible that beta is equal to 180 minus 42 degrees, which would be 138 degrees. So here's your other possibility, 138 degrees. And now we check this, 138 plus 35, this is 173, so it's still possible to have another triangle. Basically, if this would have been like 158, then that plus 35 would have put us over 180. So what we have are two viable triangles here, two possibilities that we could make out of this. So we've had some questions. Where's our good friend T-shirt of disgust? And I went and got him. I left him in my other classroom. You'll notice it's getting more disgusting. And of course, the T-shirt of disgust has two jobs. Number one is to keep the board palatable. But also, number two, I chase the students who don't hand their homework in on time. So in some sense, the distant students are lucky because this thing really is rancid. Now, me being a man, I don't mind that so much. But other people don't care for it. Okay, so, more test prep. Find all the solutions to tangent theta is equal to 2.79. And we're on the interval, and the T-shirt of disgust left a little bit of gravy on here. I guess I'll have to do this again. So we want to figure out all the solutions to tangent theta, and we're looking for all theta such that tangent of theta is 2.79, and we're on the interval from 0 to 2 pi. Okay, so this is a piece of cake. We're going to let the calculator punch in all the work here. I really should do this in radians. Maybe I'll do it in both, but I'm going to do it degrees first. 2.79 arctangent is theta is equal to 70.28115, blah, blah, blah. Also, we know that tangent is periodic with period pi, or 180 degrees. Plus 180, so, or 250.281155. I'm just going to check it again and hit my tangent. Yep, 2.79. Okay, so why is this kind of inappropriate using degrees here? Because we're on this interval. We're in radians right here, and we really should be using radians, so I'll just do it in radians, right? So this is 2.79. I'm going to radians, arctangent. So in radians, theta is going to equal 1.22663 and change. Or, remember, theta can be plus pi because it's period, right? It has period pi, plus pi. So this is radians. Or it has 4.36823, blah, 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 radians. Also, I'm going to be careful. I'm going to check it. I'm just going to, for a 4.36 whatever, I'm going to hit the tangent button again, and yeah, 2.79. Okay, so that's this 9-minute section. I got a couple more problems for you to see, and we'll be right back.